Hello guys, a warm welcome to Abstract Logic. Today we are going to be discussing referencing versus copying operations in Python. It's extremely important for you to know the difference between the two, as Python's way of handling variables and their associated values is very different from most of the programming languages, and you will want to know whether you are operating on a reference or a copy of it. So let's get right into it. For the purpose of demonstration, I will be using VS Code. However, you can use any editor, any IDE that supports Jupyter Notebook. Let's look at the application connection configuration a developer has when trying to connect to the application backend. You have some user detail, their clearance level, and the database to connect to are specified. What you want is to be able to create new configuration based on this template without affecting the original one. So if you're new to Python, you would try something like you'll attempt to set the environment to say production, right? And let's say you change the database port to say 1000, 9000, and you simply run the cells. Now when you try and log the newly created object, you see prod config. The desired changes have been affected, but the question is, has base config been affected? And when you print base configuration, you find that that has also been modified, which is obviously not what we desire. So the catch here is that Python by default, when you assign an object using the syntax shown, what you essentially get is a reference to the object. Let's say that your base config is present at the memory address hexadecimal AA BB CC. Then what will happen is that when you just declare a new variable via assignment, that is the way prod config is defined, what you will get is essentially the same memory address that base config points to. And therefore, when you try to modify prod config, base config also gets modified. So how do you know when you have created a copy as opposed to just using a reference? So Python provides you with two ways to identify whether you are using a reference versus a copy. So the most simple one is the is operator. So when you do prod config is base config, right, the truth value of this will be printed and the output here will be true. That is because by default it's the same memory address. Another way to get this is checking the ID of the variable. For every variable that you define, Python assigns it a unique ID. So let's check the ID of prod config as well as the ID of the original object. Okay, let's compare these two. These two are equal. So what is actually intended is for you to create a copy. So we have two ways to create a copy. One is to use the built-in copy method on the object, by default available on all the factory containers. So all lists and dictionaries in Python will have their built-in copy method. So when you define a new configuration with the copy method, let's see what happens. So what you get here is the ID. We make the check on ID. Now there are two different objects with two different memory locations. Now when you try printing base configuration, what you find is that its environment attribute is the same that was initially set to, that is development. However, the database port, which was declared to be 5432 in the initial creation, but is now changed to that what we changed for the prod configuration. So what is happening? So this is what is called as a shallow copy operation. What happens is that the copy method available on the list and dictionary containers is a shallow copy. That is, only the topmost level of the container is copied. In other words, the children are not copied recursively and point to the same memory address as that of the children of the original object. So what we therefore need to do is to create what is called as a deep copy. We'll import the copy module in Python, which is built in, you don't have to install it. And we will create a deep copy. Now when you check base config, it's exactly the same as what was initially declared. This is what I would call as default configuration nightmare. Now let's look at a few more examples where copying and referencing must be distinguished. So the next example that we are going to look at is the undo redo buffer. Let's say you have a custom defined class such as player, right, where the player has two attributes, a name and a position, and you want to capture the sequence of positions that the player goes through. What you want to do is track the player's state at any given point in time with, let's say, a history list. Is append to this list the initial state of the player. Let's say now you move the player to a new position. Let's say x equal to 100, y equal to 100, and you track this as well. Now what happens, as you can guess, the custom defined object called player is accessed via reference. So if you try to assess the truth value of the two objects being different or identical, you will find that the two are essentially the same. And since this is a custom defined object, we do not have a copy method present by default. That's when you will have to use the copy module that we have imported. So what we do is create a deep copy of the P1 object, because as we saw earlier, a shallow copy is just not enough. Let's call this P11. We'll have to execute the above cells again. So you create a history list, append to it the initial state by moving the player to a new position. So you set the position attribute to x equal to 10, y equal to 10. Right. And then append the new state of the player. So when you try to print the state at each point in time, let's say at t0, the player is at position state.position, and when you actually log your history, what you find is that the player hasn't moved at all. It's at the same position that we declared later, that is 1010. Here again, what we have done is captured the state by reference, but we just saw in the earlier example that this is not the correct way to work with objects, and what we'll need to do is to create a copy, specifically a deep copy of the object. Let's call the new state of the player as p11, a copy dot deep copy of the initial player, and on this player that we will modify the position attribute to 1010, and then we will append this player to the list. Now when you try and print the history, here you will get two different states. This is what is called as the mutable default argument. So let's say you have a function for e-commerce shoppers add to cart, when the user specifies an item and you have an empty cart, and what you want to do is add the specified item to the cart and return the cart. Sounds simple, doesn't it? Say you have user1 items defined as add to cart. Let's say the first user wants to buy an umbrella, and let's say you have another user that wants to buy, say, a keyboard. You would expect by intuition that user 1 and user 2 would have different items and only one object each, that is the items that they want to buy. However, the output that you get is that the both shoppers end up having exactly the same items in their cart. I mean, this is disastrous. Now, why this happens is because Python evaluates the cart only upon the first run of the function, that is when the function is defined. Any subsequent calls to the function do not reevaluate cart, but rather end up using the same cart and thus end up adding to it. So what you actually want to do is to use a reference that cannot be mutated. So we will set cart to none and check if cart is none. You will create a new cart and append to it. So what happens is that for a new user, you get cart being equal to none, and you will create an empty cart and then append the objects that the shopper is interested in. While for an existing shopper which has some items in its cart, you will end up extending that list. So let's evaluate our two users once again, and now you have the items that were added by the users themselves and not someone else's item spilling into their cart. If you're still here, I reckon that you have liked the video. Please don't forget to like, subscribe and share. Before we wrap up for today, here is a quick pro tip for you. What is called as the interning variable. So let's define two small integers. Let's say x equals to 255 and y being set to the same value. Even though the data held by the two variables x and y is identical, you would expect them to be stored at two different memory addresses. But when you try to assess the truth value with the is operator, you find that they are the same because Python usually caches small integers, generally in the range -5 to 255, to save memory. From what we just learned, does this mean that any changes that we made to x will also be propagated to y? Let's check this out. Let's say we modify x in place. However, x and y are different. If they were referencing to the same memory address, then you would expect x and y to both have been changed. However, only x has changed and y hasn't. So an integer variable in Python is essentially immutable. That is to say, you do not assign at the same memory address a new value to the variable. Let's say the original x was stored at the memory address, right? And then when you assign x to a new value, you would expect it to be present at the same memory address. But no, what it actually does is that the value 250 will be created at some other memory address, say AA B2200, and x is made to point to the new address. So in essence, you don't have to worry about data types such as integers or floats, but what you do need to be worry about is containers, that is data structures such as lists, dictionaries and other user defined objects. Thanks for watching this video and see you in the next episode.